Now, let's look at this next set of problems, which has to do with 4.3. So, in section 4.3, you learn about the certain formula, okay? This question here says the probability that Sam will be accepted by the college of her choice and obtain a scholarship is 0.35. If the probability that she is accepted by the college is 0.65, find the probability that she will obtain a scholarship given that she is accepted by the college. Okay. Alright, so this is what we do. Here's the formula. It is P, probability of B over A, like this, is the probability of A and B happening over the probability of A. Okay? So here, I just write the numbers in. The first one, because it says here, accepted by the college of her choice and obtain a scholarship, write that number, 0.35 here. Write the other number, 0.65 here. Divide those in the calculator, and you end up with 0.54. And that's all you gotta do. Okay? As far as I know, they're not going to give you any hard ones where you're going to have to, figure something out here. This next one is the same way, same formula. It tells you that 57% have a lifetime membership and golf regularly, okay? And then they tell you that 70% golf regularly. We need to find the same thing. So, same formula, 0.57 divided by 0.70, and that's going to give me 0.81. I'm just going to do it over there. Alright. So hopefully those make sense how you use the formula. Okay, let's talk about independent, dependent events. So it says here, suppose you will toss a coin and draw a card from a standard deck. Are these events independent or dependent? Hey, here's the thing. Dependent means that your one outcome depends on what happens in the first one. Whether I toss a coin and I get heads or tails has no effect on whatever card I'm going to draw from my deck. So these two events are definitely independent of each other. The next one says, suppose you are a doctor studying smoking excessively and having lung cancer. Are these events independent or dependent? Well, because one of the ways to get lung cancer in many people is by smoking excessively, it's definitely going to be dependent, okay? You have to make sure whenever you're doing these that, one outcome depends on the other one happening. Okay. Let's move along to the next problem. Okay. Here it says you're going to roll a 6-sided die and draw a single card from a standard deck of 52 cards. Now, again, these are independent events. It doesn't matter if I get a 3 and I draw a king, okay? It says here, what's the probability of rolling a 2 and drawing the king of hearts? Two separate things that are happening. Whenever they're telling us and, okay, I'm going to multiply these two together. So first things first, what's the probability of rolling a 2? Well, there's 1 2 out of the 6 whenever you roll a die. So get a 1 out of 6 chance of rolling a 2, right? What is the probability of drawing the king of hearts? Well, there's only one of them in the entire deck, so 1 out of 52. And I told you I'm going to multiply these two together, which is going to give me a rather big number in the denominator of D, 1 out of 312, okay? So in this case, using that word and, two separate independent events happening, you're multiplying. Now, this next one says, suppose 4 cards are drawn from the deck of 52 and not replaced. Find the probability of getting at least 1 club, okay? And then it says, what is the complement of getting at least 1 club as a hint? Well, this is why this is easier to do it this way. You're going to look, the complement talks about taking the likelihood of not getting a club, okay? So the complement means not getting it, not happening. So we do 1 minus, because we're trying to find the probability of it happening, but it's just easier to do it this way. So 1 minus this. And these events, okay, watch what I'm going to do here. I'm going to multiply them together, okay? And what's going to happen is, because I'm drawing the cards and I'm not replacing them, my numbers are going to go down. Every card that I take, there's going to be less of them. Alright, so I already told you earlier that with clubs, there's 13 of them in the deck. So I do 52 minus 13, which gives me 39. Okay? So, I'm looking to not drawing clubs. No clubs at all. So my first thing, what's left over are 39 cards. So I'm looking to get 39 out of 52. That's what I'm thinking, is I got that. Then, I'm going to multiply by, I'm going to draw again. 38 out of 52. Again, I didn't get a glove. That's what I'm thinking in my mind. Didn't get a glove. Keep going. Oh, not 52. I'm sorry, 51. Wasn't even thinking. 51, it goes down because I have one less card from drawing earlier. Keep going. 37 out of 50. And last but not least for the fourth one, 36 out of 49. Multiply all four of these together. 1 minus that is going to end up giving me 0.696, okay? Because the likelihood of this happening is going to be pretty small, correct? I mean, likelihood of, not using a club, sorry. So 1 minus that is going to give me 0.696, which is, about 69% that I would draw a club on my first 4 draws. Okay. Alright. I'm going to move along to the next section. And I'm going to stop. Well, no, actually, I'm not going to stop. I'm going to keep going because this is actually a pretty short section. Okay. It says, how many different ways can 6 video games be arranged on a shelf? Okay. If you know about factorials, this is actually 6 factorial. Okay, well 6 factorial is the same as doing 6 times 5 times 4 times 3 times 2 times 1. And this ends up being this number, 720, right here. Now, why is it like that? Well, I have 6 ways of putting game 1 on the shelf. Since these are 6 different games, once I put game 1 on the shelf, I have 5 games left, okay? Now I have 5 choices to put the rest of the games on the shelf. And it keeps going down. Multiply all of them together. And that's how you get 720. The next question says, what is a factorial? On your calculator, on most people's calculators, you're going to look for this button that says PRB. And that's going to take you to a menu that's going to have this and like NPR and NCR. And we're going to talk about this one later because we're going to need that for some problems, okay? A factorial, punch that in the calculator, or if you don't have something to do it, it's 8 times 7 times 6, and so on, like we did with 6. This is going to give you a really big number, C, right there. So, let's keep going. Okay, considering the following. Okay. Now, this is saying Lincoln wants us to create a 5-character password to log on to campus computers. The first letter could be A or B. I only have 2 choices, A or B. The second letter must be a digit, 0 to 9. Here's the thing, 0 to 9, that's 10 choices, 10 numbers there, okay? Because 0 counts as a number. And the last 3 characters must be a letter from the alphabet. Well, there's 26 letters in the alphabet. So the first one says, how many different possible passwords if repetition of letters are allowed? You will always have more passwords. I'm going to do this down here. More answers, okay, to this, more possibilities if repetition is allowed. Now, the first one, I have 2 choices, A or B. That's it. Nothing else. Second one, my number, I have 10 choices. Pick any number I want. And then next, I have to pick 3 letters. Now, repetition, I can do AAA. So I can do 26 times 26 times 26, and I punch that into a calculator, and I should get D. Okay? This next one says, letters cannot be repeated. So, you have to take into account that my first one is going to be a letter. And if I pick A, I can't use A anywhere else in the password. Or if I pick B, I can't use B anywhere else in the password. So, for this one, in red, this is going to be set up the same way. 2 times 10. Now, once I've used A or B, any other letter from the alphabet can be used except for that one I picked. So, I only have 25 out of 26 choices. That looks more like a 3 than a 6. I have 25 out of 26 choices left for my alphabet. And then for the next one, 24 and 23. Punch that into a calculator, and you should end up with D. Okay. Now, that was it for section 4 form. I'm going to stop there before I move on to chapter 5.